Let's start now for lesson 3 in chapter 14, which talking about the right triangles and trigonometric ratios. In this lesson, we are going to find the length of sides in a right triangle and to find the measure of angles in a right triangle. Inshallah, it will be a very easy lesson. In this lesson now, we are knowing in chapter 13 and chapter 14, we talk about the trigonometric functions. And in grade 9, I think, we talk about the trigonometric ratios, which is the sign is like it is an opposite over hypotenuse and so on. Today now we are going to see the relation between the trigonometric ratios and the trigonometric functions. Now, so there's a connection between them as I told you before. The connection is that the right or the trigonometric ratios, sine, cosine, and tan, and the other three ratios are working only in right triangle. I mean, if you have an acute triangle, if you have an obtuse triangle, you cannot use these ratios. These ratios, sine, cosine, tan, cotan, cosecant, cosecant, are only working in right triangle. So for the right triangle here, we have two things you need to remember them. One of them is the Pythagorean theorem, and one of them is the trigonometric ratios. These two are only working in right triangle. You cannot find, or you cannot use the Pythagorean theorem to find the length of this side. See, this cannot work because this is not a right triangle, and you cannot find the sine of this angle because this is not a right triangle. So for the right triangle here, you have to know that two things that can be used only: Pythagorean theorem and the trigonometric ratios. The trigonometric ratios that we know them before, which they are sine, cosine, tan, cotan, cosecant, and cosecant. And for the sine, we know that its ratio is opposite over hypotenuse. And for the cosine, it is the adjacent over the hypotenuse. And for the tan, since the tan, we know it before that it is sine over cosine, and we know that for the right triangle, the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. So we cancel them, so you can get that the tan is opposite over adjacent. And we know that the cotan is 1 over tan. So it's mean 1 over opposite over adjacent. It's mean that it is an adjacent over opposite. This is for the cotan. For the cosecant, we know that it is 1 over sine. So that's mean it is an hypotenuse over opposite. Just put the reciprocal of sine. And the secant, it is the reciprocal of cosine. That's mean it is an hypotenuse over adjacent. So here, this is a relation between the trigonometric ratios in right triangle and the trigonometric functions that we know them before. So all of these ratios are which are, they are opposite and hypotenuse over opposite over adjacent and so on, are only working in the first quadrant of the unit circle. This is here, the unit circle that you have it. I mean, like, it's only working between 0 and 90. So if this is here my right triangle, or in your book it's written like this is point here as an example. So this R will be the radius of the circle. This is will be, since this point here has an XY, so this will be X and this will be Y. And then from here we can find that X is R cosine of theta and Y is R sine of theta. So look at this unit circle here. They can find the trigonometric ratios from the unit circle. And this is the relation between them. That the sine, they found that sine is Y over R, and the cosine is X over R, and the tan is Y over X, and cosecant is R over Y. This is here how we can find them from the unit circle. In other words, you can say that this is an angle theta, this is here opposite, this is here adjacent, and this is here the hypotenuse. And the sine is the opposite over R, yani, which is the opposite over hypotenuse. Cosecant is an R over Y, which is the opposite or the reciprocal of sine, which is hypotenuse over opposite. This is here, how can you find them from the unit circle? From the triangle, as I told you before, if you have a triangle in the quadrant here, this is the hypotenuse, this is the adjacent, and this is the opposite. Now, how can we know where's the opposite and where's the hypotenuse? As I told you, in right triangle. So the hypotenuse, what's the meaning of hypotenuse? It is the longest side in the right triangle. So I will see where's the longest side. This is the longest side. So this will be the hypotenuse. And the hypotenuse will not change, but the opposite and the adjacent will be changed. If this is my angle theta, opposite, this will be the opposite side. And this will be its adjacent side. But if I have this triangle now here, and this is the longest side, so this is the hypotenuse. So that's mean if this is my angle theta, here will be the opposite side, and here will be the adjacent side. So you have to know where is the opposite and where is the adjacent. Now, for the, if theta is an acute angle, so if I have sine of 120, it cannot work. Sine of 210, it cannot work. Only for angles for the right triangle, only for angles from 0 to 90. For these angles from 0 to 90, I can use these ratios. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and so on. So I will repeat. These trigonometric ratios only in right triangle, and the angle theta must be an acute angle. Acute angle, it's mean less than or greater or between 0 and 90. So if there's sine of, if the angle is 53 as an example, I can find its ratio from the ratios of the length from the triangle. So it must be an acute angle and must have a right triangle. If these two options occur, I can use these trigonometric ratios. We must have a right triangle and acute angle. Is it clear?
Yeah, so it would be always like this drawing.
Is it clear? Do you have any question?
No, teacher, thank you.
Let's have now these examples here. Trigonometric values beyond the unit circle. For a standard position angle determined by the point 8, -6, what are the values of the 6 trigonometric functions? Here now, what did we have? We have, this is x. Here we have, this is, imagine that, we have here an unit circle. For this unit circle here, this is x. This is the radius of the circle. And here, we have y. So then here now, we have our triangle. This is x, this is y, and this is r. Now, what do we need to find now? We need to find which is x and what is y. From the here, what is the value of x?
It's 8.
8. So here, this is 8. And here, this is -6. Now, what did you need to find now? You need to find the radius of the circle. How did you find the radius of the circle? Since this is a right triangle. Pythagorean theorem. So this is a right triangle. So r squared will be 8 squared plus -6 squared. After you find it, you will find that r is 10. Okay, so now we have here as an 8 is x, y is -6, and r is 10. Now, then now here, what did you need to find? You need to find sine. Sine of angle theta. Now, where's the angle? Here, now, you need to find where's the angle. Now, here they told me that this is my angle, theta here. So, what does it mean? And we know that from the early on in chapter 13, we know that there's something we call it coterminal angle. Coterminal angle, that they are two angles, have the same terminal side. I mean, like, if this is here, one of the angles. So this here will be its coterminal angle. Both of them have the same terminal side, and both of them have both of them are equal. So that means they are equal in sine and cosine, and they are equal in the trigonometric ratios. So that's mean since this is theta here, and they have the same coterminal angle, so this angle, other angle, which is here, have the same trigonometric ratios because they have the same terminal side. So if this is theta, or can say this is alpha and this is theta, they are coterminal angle. They have the same trigonometric ratios. So this is now here my theta. I need now to find its sine, its cosine, its tan, cosecant, cotan, and secant. Let's start now with the sine. Where's the sine of the angle theta here? From the ratios, we know that sine is an hypotenuse, is an opposite over hypotenuse. Now, where's the opposite?
-6.
It's -6. And where's the hypotenuse?
10.
10. Now, cosine. Cosine is an adjacent over hypotenuse. Now, where's the adjacent?
8.
8.
It's 8.
And the hypotenuse 10. And tan, it is an opposite over hypotenuse. Where's the opposite? It's -6. And the hypotenuse, it is 8. Sorry, the adjacent is 8. So the tan here will be -6 over 8. Now let's find the cosecant. Cosecant is a reciprocal of sine. I mean like it is 10 over -6. And cotan, it is a reciprocal of tan. So it is 8 over -6. And secant, it is a reciprocal of cosine, which is 10 over 8.
It's like the reciprocal is the hypotenuse, right? And the opposite, it's 8. I mean 6.
Wait. What's your question?
Teacher, I say that you mean by the reciprocal that it's the hypotenuse, right?
How reciprocal is hypotenuse?
When you say the reciprocal, I don't know. You say the
no. If you have 3 over 4, what is the reciprocal of 3 over 4?
4 over 3.
Okay. So the reciprocal of secant is 1 over cosine.
You mean,
so the reciprocal of since cosine is 8 over 10, so its reciprocal will be 10 over 8.
The teacher, in the reciprocal, do we change also the signs?
No.
No need, right?
Don't need, just flip it.
Okay, teacher. Thank you.
Yeah. This is here how to find the 6 trigonometric ratios from the triangle. Are they clear?
Yeah.
Yes, teacher.
Now, in the triangle ABC, angle C is a right angle. So now, here we need to draw my triangle. This is a right triangle at C. So I need now to draw right triangle. And I need now to name that angle C is a right. So this is A and this is B. And sine of A is 5 over 13. I need to find cosine of A, cotan of A, and sine of B. Sine of A is 5/13. So from here, I can find that this is an opposite and this is an hypotenuse. So where is angle A? This is my angle A. So for angle A, its opposite is 5 and the hypotenuse is 13. So if this is 5 and this is 13, I can find the length of angle AC of line segment AC by the Pythagorean theorem, that 13 squared will be 5 squared plus x squared. So 13 squared minus 5 squared, which is 169, minus 25 will be 121, I think. 169 minus 25. No, 144. So that's mean x will be 12. So here, the length of this side will be 12. So from this side of A, I can find the opposite, the hypotenuse, and then I can find the adjacent. After I fill now my triangle, I need to find now what is cosine of A. I know what is my A. A here now is an, is this angle.
It's
So the
adjacent
cosine is the adjacent over hypotenuse. Now where is the adjacent?
12.
Angle A, it's a 12. And where's the hypotenuse?
13.
It's 13. So the cosine of A will be 12/13. Now let's find cotan A. Cotan is an 1. Now from the reciprocal functions, we know that it is 1/tan. And I know that tan is an opposite over adjacent. So the reciprocal of it will be an adjacent over opposite. So I mean, where is angle A? I find it now. What is the adjacent of angle, or which side is an adjacent side? It's a 12. And which side is an opposite side? It's 5. So the cotan of A here will be 12/5.
Teacher, do we simplify them like 12 and 13?
No, here, no, you cannot. If they are 6/8, you can say they are 3/4. You can simplify. But here there's
I can leave it like that.
Yeah.
Okay.
So here we find cosine of A, cotan of A. Now let's find sine of B. Sine, where can I write it? I will write it here now. Sine of B will be. Now this is my angle B now. It's opposite
over hypotenuse,
which is 13. So here, not say that, opposite here is 5. No, the opposite and the adjacent will be changed according to the angle or to the which angle I'm talking about. Hypotenuse will be the same, but for the sine of B, for the angle B, the opposite will be changed. It will be, this is the opposite side, which is 12. Is it clear?
Yeah, teacher, you know the thing that I liked in these lessons, that like each lesson has like a completely different idea, you know? Like you can understand this lesson alone and the other lesson alone. I feel like that.
Yeah, sometimes, yeah. But there's a relation between them.
Yeah.
Here now, let's talk now. Before going to gut 3, is this properly clear?
Yes, teacher.
Yeah.
Okay. Now here, in the triangle DEF. So here, as you know, you need to draw the triangle. angle D is all right. So this is D, this is E, and this is F. And tan E is 3/4. So now I know that tan I need to find sine E and secant F. Now, tan of E is 3/4. So that's mean this is my opposite, and this is my adjacent. So for angle E, the opposite is 3, and the adjacent is 4. So from the Pythagorean theorem, after you've solved, you will find that the hypotenuse is 5. After we
And
know that,
angle is in the ear.
now what is sine E? I need now to find sine of E. Sine of E, we know that it is an opposite over hypotenuse. Now where's the opposite of E?
It's 3.
And where's the hypotenuse?
5.
5. So the sine of E will be 3/5. Now let's find secant of F. Secant. What is the formula of secant here? Or what is the ratio of secant? We know that secant is 1 over what?
1 over cosine.
1
So it is
over
hypotenuse over
cosine
adjacent.
of F. And cosine, 1 over cosine, I mean like it is an hypotenuse over adjacent. Now, let's go now. I need angle F now. Where is the hypotenuse of angle F? It is 5. And where's the adjacent side for angle F?
It's 4.
It is, no, sorry.
3, right?
3.
Yeah.
So the secant of F will be 5/3. Is it clear?
Yes, teacher.